Our first one today for the quiz. So we're day 3 matrices and their inverses. And today you guys have your quiz, which hopefully you finished today. So then you can go ahead and not have to worry about trying to catch up on anything over spring break. Remember, final exam will be May 20th. Final exam is May 20th. It is early because senior grades will be due. I think we have a day or two to do senior grades after that. So that is the date that they were saying for senior finals. So everybody's going to be taking at that time. So that's our important date to know. But let's focus on our inverses today. First question says, which value of x would make the following matrix singular? Well, what does it mean to be singular? To be singular if it doesn't have an inverse. And it doesn't have an inverse, so what makes it singular is when the determinant is equal to 0. So in other words, what does x have to be for this determinant to be 0? So remember, if I want to find the determinant, I'm going to go ahead and I'm going to do 5 times my 6 minus 3 times x, so 3x. And we want to know what is that value of x going to be so that it's 0, so that my determinant's 0, because if it's 0, there's no inverse, which makes the matrix singular. So I go ahead and I solve this out. I get 30. Oh, let's get the pencil that works. There we go. 30 minus 3x is equal to 0. Subtract 30 from both sides. And I get negative 3x is equal to negative 30. Divide both sides by my negative 3. And you guys end up with x is equal to 10. Done. Negative and a negative is going to make those positive. So it's a positive 10. Be careful because they try to trick you and they also have that negative 10. So it is a positive 10 because you had a negative 30 and you were dividing by a negative 3. Tricky, tricky, right? So it's the little mistakes that will get you guys. All right, my next one. You're given this matrix and it says, which one of these is going to be the inverse? Which one of these is the inverse? So when I first did this, I was multiplying the scalar out, but notice how your answers are written. And so I'll talk about that as I go through it of what I did originally. So if I want to find the inverse, remember the inverse is equal to 1 over the determinant of that original matrix. I switch my A and my D location. So I switch the spots of these two. My B and my C location stay the same, but I take the opposite signs. Always the case to find the inverse. So if I want to follow that thought process, then the first thing I need to do is I need to find the determinant of this matrix. So if I want the determinant of that matrix, the determinant is going to be 1 times 2 is going to be 2 minus my negative 1 times 3 is a negative 3. A negative and a negative is going to make that a positive. So my determinant is going to be a value of 5. Then to find the inverse, to figure out the inverse. The inverse then is going to be 1 over that determinant, which is 5. I switch the locations of these two switch spots. So this becomes a 2 and a 1. My other two values stay in the same spot, but they take the opposite sign. So this positive 3 is a negative 3. This negative 1 becomes a positive 1. So when I went and I was continuing on because I wasn't paying attention to my answer choices, I went ahead and I was distributing this through to each piece, which is not wrong, just depending on how your answer is written. So in this case, they left it like this. There's your answer. They could have also written it as 2/5, negative 3/5, 1/5, and a 1/5. So they happen to leave it written like this, but this isn't wrong either. So look at how your answers are written. So they'll be written one of 2 ways. So you should be able to match them up, but just pay attention. So I did this my first time around. And then I was like, oh, wait, I did extra work. I didn't even need to do that if I would have paid attention. So just things to point out to you guys. All right, my next one, it says you're given matrix S and T, and it says which statements are true. Okay, so matrices S and T are not inverses of each other because S plus T does not equal I. Okay, so first of all, since they are not inverses of each other, I could solve and see if they're inverses of each other, but before I even get there, this isn't noted correctly, because if I add them together, and it doesn't give me my inverse, that doesn't make them not inverses of each other, or my identity, I should say. That doesn't make them not inverses of each other. This operation of addition is not correct. They would have to be multiplied when we're talking about inverses. Does not work with addition. So this is not going to be the case for number one. That doesn't involve it. It doesn't make it inverses if I add them. So I need to make sure I pay attention to that. My second statement says that they are inverses of each other because ST is equal to TS, which is equal to my I. So are they inverses? In other words, they're saying that they are inverses because these equal my identity. What is that telling me? So I'm going to do some work up here. So I'm going to do my ST. So I'm going to multiply my S by my T. And so when I do that, I get 4 times my -8. So 4 times my -8 plus it's going to be 11 times 3. I get 4 times my -11 plus 4 or plus 11 times 4. My second row here is going to be -3 times my -8 plus -8 times 3. My next one, my doing bottom row, second column is going to give me -3 times -11 plus -8 times 4. And of course, I could clean this up. So when I look here, it's going to give me -32 plus 33. This is going to give me -44 plus 44. This is going to give me positive 24 minus 24. This is going to give me positive 33 minus 32. So when I write it all cleaned up, this is going to give me 1, 0, 0, 1, which is my identity. So ST is equal to my I. That part is true. Yes, that part is true. But do I know that TS is also equal to it? Because remember, is it commutative? And no, it's not always commutative. Could it be? Yeah, if they're inverses, they're going to be commutative. But S times T isn't always the same as T times S. Remember when we did our matrices and they're different sizes, so you had to do it in that certain order. It makes a difference. So I would also have to check my TS. So TS. So when I talk about my TS, I'll do this in a different color. Let's do. Then it's going to be going this way, and these are going to become it. Sometimes just because of the way I look at things, if I wanted to rewrite my S on this side so that I can see it's my 4, 11, -3, -8. Since my T is first and I want to look at it this way so that I'm keeping it so that I don't accidentally switch things around, personal preference. Again, I just like to do that so I don't make mistakes. Okay, so I'm going to do, then I need to check this matrix. So it's -8 times 4. So my T is first now because T is first here. So it's row columns. So it's going to be -8 times my 4 plus my -11 times my -3. And then I have my -8 times my 11 here plus -11 times my 8. And then I'm going to have my 3 times my 4 here, plus my 4 times my -3. And then I'm going to do my last row and my last column, and that's going to be 3 times 11 plus 4 times my value of -8. That's a negative right there, so I didn't pay attention. So it's negative up there. Let me do that, copy that right. My negatives. Let me make sure I lined my things up right. So I did my negative, watch my signs here, -8 times my positive 11. Okay, so this is -11 times my -8. That's right, this is a positive. And then that was my negative. Make sure I get all my signs right. All right, then we could go ahead and we could clean it up. So I end up with negative 32 plus 33. This is going to give me negative 88 plus 88. This is going to give me 12 minus 12, and this is going to give me 33 minus 32. And look, I end up with 1, 0, 0, 1. So this one right here is true. They all equaled the identity. When I multiplied them, it was equal to the identity. That is a true statement. It says matrices S and T are inverses of each other because the determinant of S is 1. That doesn't automatically make them inverses of each other because that determinant is 1. Remember, the determinant is used to help us. So the determinant's used to help us. That just because this is 1 doesn't make it an inverse. So that's not true. They are not inverses of each other because the determinant of S equals the determinant of T. That does not determine it either. Remember, this determinant value doesn't matter what it is, it could still be inverses depending on what values are in here when you switch them and you simplify it. It just means that the inverse exists. So kind of a lot to go through on that problem. Any questions on it before I do move on? Alrighty, well, my next one then, flipping it over, I have, which of the following matrices has an inverse? So remember, it has an inverse and the determinant does not equal 0. Well, in order to find the determinant, what kind of matrix are we working with? Must be a square matrix, right? It has to be a square matrix. All right, well, which one has an inverse in? I have to make sure the determinant's not 0, but it needs to not be square for me to figure out the determinant. And look, or it needs to be a square for me to be able to figure out the determinant. So it can't be this one, it can't be this one, and it can't be that one because none of them are square. So I can't find the determinant. So it must be this one, but let me just double check that my determinant is not equal to 0. I'd hate for maybe there was no solution. So again, my determinant cannot be 0. So this is going to be 6 times 1 is 6 minus 2 times negative 9, which is going to be a negative 18. So my determinant was 24, which is not 0. So this is the correct answer. I could have picked it out again because it was the only square one. So just things to think about. And then our text code one. So I actually kind of think these are kind of fun. Okay, so Yvette encoded a secret message using matrix multiplication. So it says A is equal to 1, B is equal to 2, C is equal to, and so on. They're just using the same one that we talked about yesterday. That's why I was saying this. Some of the problems had this, some of them don't on the quiz. I even think on the quiz, some do and some don't. So I just went ahead and I used my printed copy when I was going through and doing it. So she's multiplied the clear text code for each letter by the matrix C to get the matrix that represents the encoded text. So she took her matrix C and she multiplied it by the clear text code. And when she did that, she got the encoded text. So that's what the statement's saying. And this is the same as what we did yesterday. The matrix representing the encoded text is here. What is the secret phrase? So what we're looking for, that secret phrase, is the clear coded text. This is the secret phrase. So I need to get rid of this C value. And in order to do that, I multiplied by its inverse so that it cancels out. So I get that my clear text code would be my C inverse times that encoded text. So we need to figure out the inverse of this and multiply by our encoded text to get our clear text code, to get what we want so we can figure out what our message is. So first thing I need to do is figure out what is the inverse of C. So I'll go right up here and I'll do right above. So C inverse is going to be 1 over my determinant. Oh, what's the determinant here? So my determinant is going to be 5 times 1 minus 2 times 2. So it's going to be 5 minus 4, it's just the value of 1. So it's 1 over 1. Easy peasy to work with. Then remember for my inverse, I switched my two values here. So I'm going to switch my 1 and my 5. My 2's now both become negative. So my inverse is just going to be 1, negative 2, 5. So my inverse that I'm going to be multiplying is going to be 1, negative 2, 5. So there's the inverse. The encoded text is this value right here. So it's going to be my 48, 73, 114, 30, 136, 78, and 35. I'm going to have 21, 32, 50, 13, 58, 35, and 15. Order matters, of course, because if I switched them, I wouldn't be able to multiply them. So the order does matter. That inverse is going to be out in front. So it's going to be my rows and my columns. So again, this is a 2 by 2. This is going to be a 2 by 1, 2, 3, 4, 5, 6, 7, 2 by 7. So I can multiply because my inners are the same. My new one is going to be a 2 by 7. So this is our new dimension. Just a little bit of a review there. All right, so when I multiply them, what am I going to end up with? So let's go ahead. Let's do our first row. Our first row to each one of these columns. So it's going to be, I'll multiply it through as we go through. Well, I don't know what's better for you guys. It's kind of a long process. So 1 times my 48 plus negative 2 times 21. Then we're going to have 1 times 73 plus negative 2 times 32. I'm not going to multiply that one. I'll just go ahead and write that value. So it's going to be 114. And then it's going to be plus negative 2 times my 50. And then it's going to be 30 plus a negative 2 times my 13. And then it's going to be 136 plus negative 2 times my 58. And then it's going to be 78 plus negative 2 times my 35. And then I'm going to have 35 plus negative 2 times my 15. Barely fitting it on there. And then I'll go ahead and I'll do my second row there. So my second row is going to be negative 2 times my 48 plus 5 times 21. It's going to be negative 2 times 73 plus 5 times 32. It's going to be negative 2 times my 114 plus 5 times my 50. This is going to be negative 2 times my 30 plus 5 times 13. This is going to be negative 2 times my 136 plus 5 times my 13. This is negative 2 times my 78 plus my 5 times 35. Oh, I said 5 times 13 here. That's a 58. This is going to be 5 times my 35. This is negative 2 times 35 plus 5 times my 15. Squeezing all that in over there. Go through, let's clean this up a little bit, huh? All right, so I'm going to end up here. This is going to be 48 minus 42. This is 73 minus 64. This is my 114 minus 100. This is going to be 30 minus 26. This is going to be 136 minus 116. This is 78 minus 70, 35 minus 30. I have negative 96 plus 105. I have negative 146 plus 160. I have negative 228 plus 250. Negative 60 plus 65. Negative 272 plus 290. Negative 156 plus 175. Negative 70 plus 75. Whew. And I end up with all cleaned up, we end up with 6, 9, 14, 4, 20, 8, 5, 9, 14, 22, 5, 18, 19, and 5. Kind of a lot of work just to simplify, I know. And then we just go ahead and we match up. You shouldn't have any negatives because it's only going to be values from 0 to 26. If you don't have a value from 0 to 26, you did something wrong. So it's always going to be something so that we could code it out this way. So if I look here at my coding, I have that my 6 is going to be, my 6 matches up with F, so it's going to be an F. So you could kind of see that where it starts to differentiate up here, but it's going to be F, I, N, D, T, H, E. Notice this one didn't have zeros for the space, but it's still going to go in an order. So find the, so it's one of these first two, find the, and it says I, N, V, E, R, S, E. Find the inverse. And maybe some of you guys could have guessed that since we're working with inverses. That's all I have for you guys today. If you have any questions, let me know. If you need anything over the break, let me know. Just send me a message, email, remind, whatever way is best for you guys. I'm here to help you guys. And you guys enjoy your time off, and I will see you guys. Take care. You're welcome. Thank you. Bye, dear.